everybody in let's do that within our add fudge decorator too. Same or you add sprinkles, you add fudge, here is your chocolate ice cream. Alright everybody, so those are decorators. They're a function that extend the behavior of a base function, in this case, get ice cream. Decorators extend a function without modifying it. If you would like to apply a decorator to a function, you precede that function when you define it with @ the name of the decorator. And you can apply more than one. And well everybody, that is an introduction to decorators in Python. Hey everybody, so today I gotta talk about exception handling in Python. An exception is an event that interrupts the normal flow of a program. There are many different types of exceptions, which include, but are not limited to, zero division error exceptions, when you attempt to divide a number by 0, for example, 1 divided by 0. That would interrupt our program. We have a zero division error. Another is a type error. That's if we attempt to perform an operation of a value that's of the wrong data type. For example, 1 plus a string of 1. That would give us a type error. Unsupported operand for int and string. Value errors tend to happen when you attempt to typecast a value of the wrong data type. So let's say we attempt to typecast the word pizza as an integer. Well, pizza isn't a number. We have a value error, invalid literal for int base with 10, pizza. So exceptions will interrupt our program if they're not handled gracefully. And here's how we can do that. There's 3 steps. We can write isn't a the word p1, 0 division divided by 0. That would interrupt our program. We have a zero division error. Another is a type error. That's if we attempt to perform an operation of a value that's of the wrong data type. For example, 1 plus a string of 1. That would give us a type error. Unsupported operand for int and string. Value errors tend to happen when you attempt to typecast a value of the wrong data type. So let's say we attempt to typecast the word pizza as an integer. Well, pizza isn't a number. We have a value error, invalid literal for int base with 10, pizza. So exceptions will interrupt our program if they're not handled gracefully. And here's how we can do that. There's 3 steps. We can write a try, except, and finally block. Any code that's dangerous, where it could cause an error, you'll place within a try block. For example, anytime we accept user input, that is considered dangerous code because a user can type in anything. So let's say we have a number. Number equals, we will accept some user input. We will tell a user to enter a number. Then we're going to typecast it as an integer. Then I'm going to print 1 divided by whatever the user types in. If I were to type in 0, we get a zero division error. If I type in the word pizza, so we're going to code it and then indent any code underneath it. We're going to try this code. If an exception happens, we will move on to step 2. Subsequently following the try block, we will add an except block. If we run into one of these exceptions, we can execute some alternative code. For example, a zero division error. If somebody attempts to divide a number by 0, we can take a different course of action. Instead of our program crashing and coming to a halt, let's print you can't divide by 0. Idiot. Let's attempt to divide by 0. Enter a number, 0. You can't divide by 0, idiot. We have gracefully handled this exception. So now let's say somebody types in the word pizza when we're asking for a number. Well, we have a value error. Well, we can chain except blocks. If we encounter a value error, let's add an except block for that. Except value error. We're going to print enter only numbers, please. Enter a number. I'll type in the word pizza. Enter only numbers, please. That's good. We're not interrupting our program. Now, what you may see some people do is they will just catch all exceptions. Except exception. Now, this is actually considered bad practice. Exception will catch all exceptions. However, it's too broad of a clause. It's good practice to tell the user what went wrong exactly. If we resort to just catching all exceptions, you may see an error message such as, something went wrong. I would only catch all exceptions as a last resort. First, let's try and tell the user what went wrong exactly. So I'm going to undo all this code. If there's an exception that occurs, it's not a zero division error, and it's not a value error, then we can add that catch-all, where we catch any unseen exceptions. Now lastly, we have the finally block. The finally block always executes, regardless if there's an exception or not. It's usually used for any sort of cleanup that you need to do, such as if you're handling files. You may try and open a file, and then you'll want to be sure to close that file when you're done with it. That would be handled within the finally block, but we'll get to file handling pretty soon in the next topic. So just for the time being, I'm going to print do some cleanup here. Alright, let's test this. Enter a number. I'm going to divide by 0. You can't divide by 0. And we still execute the finally block. Enter a number, I'll enter in 1. 1 divided by 1 is 1, and we still execute that finally block. The finally block will be more useful in future videos. All you need to know is that it always executes, regardless if there's an exception or not. Alright everybody, so that's exception handling. An exception is an event that interrupts the normal flow of a program. There are many different types of exceptions. You can always look under the official Python documentation for an extensive list. And well everybody, that's exception handling in Python. Hey, what's going on everybody? Today I'm going to show you how we can handle basic file detection using Python. This topic is the first of many involving a mini-series on file handling using Python. First, we'll need to cover file detection before we read and write files. To work with files using Python, we will import the OS module. OS means operating system. This module provides a way for Python programs to interact with the operating system. Be sure to import the OS module at the top. For my demonstration, within my project folder, I'm going to create a new file. New, file. I will name this file test, and this will be a plain text file. It will have the file extension of txt. This file really doesn't need to say anything. I'm just going to type, I like pizza, because I do. The context doesn't matter. We're not going to be reading files in this video. For convenience, I'm going to assign a variable of file path. This will be a string. For file detection, we can either use a relative file path or an absolute file path. We'll cover relative file paths first. These two files are right next to each other, my main Python file and my test file. If we're using a relative file path, I only need the file name, including the extension, test.txt. We'll be passing in this string of file path as an argument. To check to see if this file exists, I will use an if statement. If access the OS module, access the path, there is a built-in method of exists. We'll pass in our file path as the argument. This method returns a Boolean value of true or false if this file exists. So if this file does exist, test.txt, let's print the following. I'll use an f string. The location, I'll add a placeholder, exists. I will place my file path within that placeholder, and I'll surround it with single quotes to make it look nice. If this method returns true, do this. Else, we'll do something else. I will print that location doesn't exist. All right, let's see what happens. The location test.txt exists. Now, what if I get the extension wrong? Let's say that I'm looking for a PDF, but it's really a txt file. Well, that location doesn't exist. You do have to be sure to get the file extension correct. What if this file was in a folder? Within my Python project, I will create a new directory. I will name this directory stuff. Then I will place my test file within the stuff folder. PyCharm wants me to refactor my code because the location changed. I'm not going to do that. I'll refactor, place my What if this free? I will within the stuff folder. I'm not going to. Well, here's what happens. That location doesn't exist. With our relative file path, we'll have to navigate to our stuff folder, then find the test file. So preceding this file name, I will access the stuff folder, stuff / the name of the file, test.txt. And now we can locate that file. The location stuff / test exists. When working with relative file paths, you may need to open up a folder, then find your file. You also could work with absolute file paths. So for this demonstration, on my desktop, I'm going to create a new file. New, text document, test. If I were to look at the properties, this is a txt file, a text document. I'm going to copy the location. Within my file path, I will paste it, then list the name of the file, test.txt. This is an absolute file path. One problem we're running into, when working with strings, a backslash does serve as an escape sequence. Python thinks we're trying to print a tab character. We can solve this with double backslashes. Slash does serve as an escape sequence. Double back. Or we could use a // does exist. There is a built-in method of isFile to location doesn't exist. There is a built-in method of isFile to check to see if that file is in fact a file and not a directory. Let's add the following. After we detect this file, we'll write a nested if statement. If os.path.isFile, then pass in our file path as an argument. If this file is in fact a file and not a directory, I will print that is a file. The location of that absolute file path does exist. That is a file. What if it was a directory, a folder? I'm going to delete this, go to New, Folder. I will name this folder Test. To check to see if a location is a directory, let's add an else if statement. Else if os.path.isDir, meaning is directory. This is a method. We'll pass in our file path. If this is a directory, a folder, I will print that is a directory. Let's run this again. That location doesn't exist. Oh, we have to get rid of the file extension. It is not a plain text file. The location of that absolute file path exists. That is a directory, a folder. All right, everybody, that's basic file detection. In the next few videos, we're going to be reading and writing files. And well, everybody, that is basic file detection using Python. Hey, what's going on, everybody? In today's video, I'm going to show you how we can write and output files using Python. We'll cover plain text, JSON, and CSV files. But we'll start with plain text, because it's the easiest. Suppose we have some data that we would like to output. I'll create a variable of text data. Think of a food you like. I will output, I like pizza. For convenience, we'll create a variable of file path. This can be a relative file path or an absolute file path. Within this file path, we'll need a name for this file. I will name this output, then include the file extension. This will be a txt file, a plain text file. This is a relative file path. When I generate this file, it will be within the same project folder as my main Python file. To create a file, we'll write the following. With open function, pass in our file path, and a character of W to write as file. And for now, I'll write pass. There's a few things going on here. With is a statement. It's used to wrap a block of code to execute. If we open a file, the with statement will also close that file when we're done with it, so we don't need to manually close files. When you open a file, it is good practice to close it, because if you don't, you may run into unexpected behavior. The with statement takes care of that for you. The open function will return a file object. The first parameter is the file path. The second parameter is the mode. W is write. X will also write if this file doesn't exist. If it already does exist, we'll receive an error. A is for append, to append a file, and R is to read, but we'll take care of reading in the next video. So we will stick with W to write a file. The open function returns a file object. The first argument is the file. The second argument is the mode. You can set these to be keyword arguments if it's easier for you to read. When the open function returns a file object for us, we're using the as keyword to give it a name as file. It's kind of like we're instantiating a file object. File equals file. File is the name of the file object. To write to this file, we're going to take our file object, use the built-in write method, then pass in our text data. Then when this is done, I'm going to print a confirmation message. I'll use an F string. Let's say text file. I'll add our file path. Place it within single quotes. Was created. Let's see what happens. Text file output.txt was created. And here's that file. I like pizza. We also have the capability of setting an absolute file path. Let's say I would like to output this file to my desktop. I would just need that location. Let me just get the location from one of these folders by going to Properties. I will copy this location. This is the location to my desktop, but for you it's probably going to be different. Then I will paste the absolute file path. A backslash is an escape sequence within a string. We either could use double backslashes or a forward slash. Now let's see if this outputs to my desktop. Text file, here's the file path, was created, and here's that file. It's a plain text file, and it says, I like pizza. Absolute file. We already have with output. It can be a relative file path or an absolute file path. Alright, now for our text data, there are different modes as well. W is to write. If we use X, we'll write a file if that file doesn't already exist. In this case it does. On my desktop, we already have a file named output, and it's a plain text file. So when I run this, with the mode of X, we get a file exists error. That file already exists. We could catch this exception so that our program isn't interrupted. I will copy the name of this error. I will place my code within a try block. We will try this code and catch any exceptions. Except file exists error. If this file already exists, let's take a different course of action. Let's print that file already exists. So now when I run this again, our program isn't interrupted. We receive this message. That file already exists. If I were to delete that file, bye-bye, then run this again, well, we create a new file. Text file, that absolute file path, was created. And here it is again. Now for the mode, there's also A to append. Any new data will be appended to that file. We get, I like pizza, I like pizza. When appending data, if you would like that data on a new line, we can add a new line character. W will overwrite a file. So we're back to the original. When appending, either before or after we write our text data, we could add a new line character. Let's do that before. New line plus our text data. Here's the output. Again, we're appending, not writing. I like pizza, I like pizza. Our second sentence is on a new line. Let's run this a couple times. We should have several lines now. Let's work with a collection. Let's say we have a list of employees. We'll pick some employees at the Krusty Krab. So we have Eugene. I guess he's technically the manager. I don't know if that counts as an employee. Squidward. Manager a couple times. We should have several lines now. Let's work with a collection. Let's say we have a list of employees. We'll pick some employees at the Krusty Krab. So we have Eugene. We should have several lines now. Let's work with a collection. Let's say we have a list of employees. We'll pick some employees at the Krusty Krab. So we have Eugene. I guess he's technically the manager. I don't know if that counts as an employee. Squidward, SpongeBob, and Patrick. Patrick worked at the Krusty Krab in one episode. He counts. Then we'll have to be sure we're writing our employees. This is what's going to happen. We have a type error. Write argument must be a string, not a list. In order for us to write each item within a list, we'll need to iterate over it using some sort of loop. We can't write a list or any other collection directly. Here's what we'll change. For every employee in our collection of employees. We're iterating over something that is iterable. We will access one long after writing. We get here. We put summary. A JSON file is made of key value pairs. For our data, let's say we have a dictionary of employee. A dictionary is made of key value pairs. We'll have a name. of SpongeBob. SpongeBob's age will be 30. His job, his position, is that he is a cook. So this is the data I would like to output. I'll keep the file path the same. We'll change the file extension to .json. We will need the help of the JSON module. Let's be sure to import that. Import JSON. Within our with block, we'll make the following change. We're going to access our JSON module, use the dump method. The dump method will convert our dictionary to a JSON string to output it. So we have to pass in our JSON data. Of employee, our file as the second argument. Then for a confirmation message, let's print JSON file was created. Here's the result. JSON file at this location was created. And here's my JSON file. I'll go to properties. We'll confirm it is a JSON file. It is. And I'll open it. Here's the result. Now, you could add indentation after each key value pair. Here's how. After our second argument, our file, we can pass in a keyword argument of indent. For each key value pair, by how many spaces do we want to indent each? Let's say 4. And let's take a look. I think that's more readable. We're indenting each key value pair by 4 spaces. So that is a JSON file. It's a collection of key value pairs. A dictionary or anything that uses key value pairs is a great candidate to be output to a JSON file. All right, now we're going to work with CSV files. CSV means comma separated values. CSV files are pretty common with a spreadsheet of data, like an Excel spreadsheet. We will create a 2D data structure of employees. This will be a list of lists. Let's add 4. Excel separated sheet. We will create CSV files are pretty common with a spreadsheet of data, like an Excel spreadsheet. We will create a 2D data structure of employees. This will be a list of lists. Let's add 4. We'll need the help of the CSV module. Import CSV. Think of our 2D data structure as a table of rows and columns. So for the first row, I will add name, comma, age, comma, job. The second row will have a name of SpongeBob, age 30, job, cook. For the next row, we'll have Patrick. Patrick will be 37. What is Patrick's job? I don't know. He's unemployed. Then we'll have Sandy. Sandy will be 27. Sandy is a scientist. Okay, now with our file path, the file extension is going to be a CSV file, comma-separated values. Within the context of our with block, we're going to create a writer object to write to a file. Writer equals access the CSV module, use the writer method of that module, then pass in our file. Writer is an object. It provides methods for writing data to a CSV file, and then we'll print a confirmation message of CSV file was created. Here's the output currently. We have a CSV file. I'll go to properties to confirm it. Well, we have no output. We have to iterate over all the rows in our 2D collection. We'll write the following. For every row in our data of employees, we'll take our writer object, use the write row method, and pass in that row that we're iterating over. Now let's take a look. That's better. However, the writer method gives us a new line after each row. So if we would like to prevent that, when we open this file, I will set the keyword argument of new line equal to no characters, an empty string. Let's take a look again. Yeah, that's much better. So this is a CSV file. It's made of comma-separated values. All right, everybody, so that is an introduction to writing files using Python. What's going on, everybody? Today I'm going to show you how we can read files using Python. We'll cover plain text, JSON, and CSV files. In the previous topic, we have created some sample files to work with. Here is my plain text file, my JSON file, and my CSV file. They're all named input. They each have a different file extension. created some plain text, JSON, and CSV files. In the previous topic, we have created some sample files to work with. Here is my plain text file, my JSON file, and my CSV file. They're all named input. They each have a different file extension. For convenience, I will create a variable of file path. We can list a relative file path or an absolute file path. I'll use an absolute file path. I'm going to right-click on the file I would like to read, go to Properties, copy the location, then paste it, then add the file name including the extension, input, and this is a txt file. Within the context of a string, backslashes are escape sequences for special characters. We would either need to use double backslashes or a forward slash I would like. With is a statement. It's going to wrap a block of code within a context manager, and it'll close a file if we open it. It is good practice to close a file if you do open it. If you don't, it can lead to unexpected behavior. We will use the open function. The open function has two arguments, our file path and a mode. To read a file, we'll set the mode to be R for read. The open function is going to return a file object, which we will give a nickname of file, as file. When we read our file object, it's going to return one long string, which we will assign to a variable named content. Content equals file, use the read method, and assign it to this variable. Then I'm going to print the content. Print our content, the content of the file. Here's the result. That is the content of my file. I like pizza, it's really good. Let's say we can't find this file. Perhaps I forget the file extension. We'll run into a file not found error. This will interrupt our program. We can catch exceptions when they happen. Any dangerous code that may cause an exception, we can wrap within a try block. If there's an exception, we will catch them by stating except the name of the exception. In this case, file not found error. Instead of our program being interrupted, let's take a different course of action. We will print that file was not found. Let's try this again. That file was not found. At least our program isn't being interrupted. Let's add the file extension back. What if we don't have permission to read this file? To demonstrate that, I'm going to right-click on that file, go to Properties, go to Security, edit the permissions. I will deny any sort of control. I will attempt to read this file, and we get a permission error. Permission denied. We could handle this exception as well. If we encounter a permission error, I will print the following. You do not have permission to read that file. Let's run this again. You do not have permission to read that file. Those are a few exceptions we can handle in case they appear. File not found errors and permission errors. Let's say we would like to read a JSON file. We will need the help of the JSON module. I will import the JSON module at the top of my program. I need to get the file path of this JSON file. It's pretty much the same as before in this case. The file extension is a JSON file. There's only one change we're going to make. We will assign our variable of content equal to access the JSON module, use the load method, and load our file. And that should read the contents of my file. Here's my JSON file. Name, SpongeBob, age 30. Job, cook. With the data of your JSON file, you could access a value given a key. I will access our content by its key of name. That will return the value of SpongeBob. Age, 30. Job, cook. Now here's how to read a CSV file. We will import the CSV module. The file extension is going to be CSV. Again, this is on my desktop in the same location as the previous files. My content will equal access the CSV module, access the reader method, and pass in our file. Here's the content currently. We're given a memory address. With the CSV file, what we need to do is read the CSV file line by line. All of the data is within a collection, which we need to iterate over. So to do that, we're going to create a for loop. For every line in my content, I will print each line. That's much better. The format resembles a spreadsheet, like an Excel spreadsheet. There's rows and columns. To get a specified column, we can access an index. In my example, our line at index of 0 would give me the first column, 527, data from a C. Those are a few ways in which we can read this video import the Python. Hey, what's going on everybody? So in today's video, I'm going to show you how we can work with dates and times using Python. We will import the date time module. This allows us to work with dates and times using our system clock, our computer's clock. This video serves as more of an introduction. To create a date object, we will assign an object of date. Let me zoom in a little bit. We will access the datetime module, call the date method. Within the date method, we will pass in the following arguments: a year of our choosing. So for me, I'll say 2025, a month. 1 corresponds to January. These are numeric months. And a day of the month. I will say the second. If I was to print the state object, here's what it outputs. The year is 2025, January 2nd. To get the date right now, let's say today. This will return a date object that represents today. Access the datetime module. Access the class of date. Then call the today method to return the date of today. Let's print today. Currently, I'm recording this video July 14th, 2024. For me, that is the result of my today object when I print it. Now we'll work with time. I will create a time object, access the datetime module, call the time method. We have to pass in hours, minutes, and then seconds. So for the hour, let's say 12, 30, and 0 seconds. I will print the current time. It is 12:30. Now to get the time right now on our system clock, I will create a datetime object of now equals access the datetime module. Now within the datetime module, there is a datetime class we have to access. We will access that. I know it looks kind of silly. Datetime.datetime dot the now method. So we're accessing the datetime module. There's a built-in datetime class we have to access. Then within that class, there's a now method. What is the time right now, according to my system clock? This returns a date and a time. July 14th, 2024. It is just after 9 a.m. We can format the appearance of the string. Here's how. I'm going to reassign our datetime object of now. Align the time. It should be aligned. Else, I'm going to print the location. Created some sample files. If our target date is less than the is one possibility. Values. CSV files are pretty common. Use the load method. If our target date is less than the current date, that means this date is one possibility. Alright everybody, so those are a few ways in which we can read files using Python. Time has passed a target exercise, or if it's datetime method, kind of silly, class we have 12 hours, minutes, and then seconds. So for the hour, let's say 12, 30, and 0 seconds. I will print the current time. It is 12:30. Now to get the time right now on our system clock, I will create a datetime object of now equals access the datetime module. Now within the datetime module, there is a datetime class we have to access. We will access that. I know it looks kind of silly. Datetime.datetime dot the now method. So we're accessing the datetime module. There's a built-in datetime class we have to access. Then within that class, there's a now method. What is the time right now, according to my system clock? This returns a date and a time. July 14th, 2024. It is just after 9 a.m. We can format the appearance of the string. Here's how. I'm going to reassign our datetime object of now. our datetime object has a string format time method, strf time. We're going to pass in a string and include some format specifiers. Let's say I would like to display the hour first. I'm going to add a %. These format specifiers you can find according to the datetime documentation online. So I will display the hours. That would be %h, %m for minutes, %s for seconds. Let's see what we're working with. We have the hours, the minutes, and the seconds. I will separate each of these with a colon. That's better. Now I'll add the date. I'll start with the month. I will add a format specifier of lowercase m, then the day, a format specifier of d, then the year, format specifier capital Y. Here's the result. We have the month, the day, and the year. I'll add a dash to separate these. That's better. Or if you prefer the day first, rather than the month, we can switch this around. It depends on how you read dates in your country. Now we're going to cover an exercise. We're going to see if the current date and time has passed a target date and time. So, we are going to create a target date time equals access the date time module. We will create a new date time. So now we have to pass in a date and a time. For my date time, let's say it's something far into the future, like the year 2030, January 2nd. For the hour, it will be 12:30 and 1 second. I'm going to get the time right now, which I will name current date time equals access the date time module, access the date time class, call the now method to return the current date and time right now. Using an if statement, I will see if our target date time is less than the current date time. Have we already passed this date? If our target date is less than the current date, that means this date and time has already passed. I will print the following if that's the case. case, target date has passed. Else I will print target date has not passed. Here's the result. Target date has not passed. What if I set the target date to the year 2020? Well, then the target date has passed. So that's how we can check to see if a date and time has already passed. Has it elapsed? Alright everybody, so that is an introduction to working with dates and times using Python. Alright everybody, so in today's video we're going to create a working alarm clock using Python. For this project, we will need the following imports. We will import time. We'll be updating our clock every second. The time module is going to help us with that. As well as import date time. The date time module allows us to work with string representations of a time. In my opinion, the easiest way to work with sound effects is to actually use Pygame, so we will import Pygame. Now you may need to download the Pygame package. Here I'm getting a message that there's no module named Pygame. There might be a link to install it even too. One way in which you can download the Pygame package is to open up a terminal, then use pip. Pip is Python's package manager. Pip install Pygame. Alright, we have our 3 imports. Let's create a function to set alarm. We have one parameter, an alarm time. And for now, I'll write pass. Our alarm time parameter is going to be a string representation of a time in military time. I would like to start this program if I am running my main Python file directly. I can add the following if statement. If dunder name is equal to a string of dunder main. If we are running this main Python file directly, then we will set the alarm. But first, we have to prompt the user what they would like to set the alarm to. So we will define a variable of alarm time equals ask for some user input. Using the input function. We will prompt the user to enter the alarm time and give a format. Hours, minutes, and seconds. If dunder name is equal to a string of dunder main. If we are running this main Python file directly, then we will set the alarm. But first, we have to prompt the user what they would like to set the alarm to. So we will define a variable of alarm time equals ask for some user input using the input function. We will prompt the user to enter the alarm time and give a format. Hours, minutes, and seconds. Again, this is going to be in military time. Once we have our alarm time, we will call the setAlarm function and pass in our alarm time. Alright, we are now within the setAlarm function. When we call this function, let's print the following. I'll use an f-string. Alarm set for, then include the alarm time. You will need an MP3 file to work with. If you don't have one available, here's one recommendation. You could use YouTube's audio library, and then search for sound effects or some music. These audio files are only allowed for non-commercial use outside of YouTube. So you can search for a song or some sound effects, find one that you like, and download it. Once you find a song that you like, move it to your project folder. Now, I will create a variable of sound file equals. This will be a relative or absolute file path. My MP3 file is right next to my main Python file. I only need to list the file name. I named mine My Music, and this is an MP3 file. I'm going to perform a test run. We're not going to play our sound quite yet. We do have this output that displays that says hello from the Pygame community. Let's say I set my alarm to 9 a.m. Then enter, alarm set for 9 a.m. If you would like to suppress this output for Pygame, we can navigate to our virtual environment, go to Library, Pygame, underneath this file named dunder_init. Let's scroll all the way to the bottom. And we should have this if statement. We display the version of Pygame we're using, and a print statement of hello from the Pygame community. We could comment this out, or even just delete it. That is the most simple solution. So we shouldn't get that message anymore. We're going to create a Boolean statement of hello from the Pygame community. We could comment this out or even just delete it. That is the most simple solution. So we shouldn't get that message anymore. We're going to create a Boolean variable of isRunning. Is our alarm clock running? I will set that to be true. While isRunning, while this is true, we will continue the alarm clock. We need to get the current time. Current time equals, we will access the datetime module, access the class of datetime. Call the now method to get the time and date right now. We could method chain the string format method, strf time. I would like the hours, minutes, and seconds, but not the date. So we will type %h, colon, let me zoom out a little, %m for minutes, and %s for seconds. We're getting the hours, minutes, and seconds of the date and time right now, and storing it within this variable of current time. Then I'm going to print the current time. We'll perform a test run. However, currently we're within an infinite loop. At the end of the while loop, I'll set isRunning to be false. Okay, enter the alarm time. Let's say 10 a.m. Alarm set for 10 a.m. And the time for me right now is 9:42 and 16 seconds. We'll get rid of this line where we set isRunning to be false. Instead, I'm going to access the time module and call the sleep method. We will pass in a number of seconds to sleep, so 1 second. I'll set the alarm to be 10 a.m. Now the time should update every second, which it is. However, when the current time is equal to the alarm time, we have to trigger the alarm. So after printing the current time, we will write an if statement to check if the current time is equal to the alarm time. If this is true, then let's print the following. Wake up. And I'll add an emoji, because it's silly. Once our alarm triggers, we will set isRunning to be false within this if statement. Let's do a test run. We're not going to play the sound quite yet. I will set the alarm to 9:45. And then I'll come back a little bit later. Alright. Once the current time matches the alarm time, we print wake up and set isRunning to be false to exit the while loop, and then subsequently exiting the program. Now we need to play an MP3 file. We will access our package of Pygame, access the module of Mixer. So Mixer is a module for loading and playing sounds, but we have to initialize it. But we're going to initialize it with init to initialize. The initialize method is another way to call the constructor. We can pass in some keyword arguments for the frequency, size, channels, buffer, all that, but that might be a little too complicated for us at this level. We'll use the default settings by not passing in anything. The next step is to load our sound file, access the package of Pygame, access the module of Mixer, access the module of Music, then call the load method. We will load our sound file. Our sound file contains the file path to our MP3 file. Once we load our music, we have to play it. Pygame.mixer.music, call the play method. Our MP3 file is only going to play for a brief second. I'll demonstrate that. I will set the alarm to 9:49 and just give it a few seconds. Our sound file stops playing when the program terminates, what we need to do next is continue playing our sound file while that sound file is busy. We will Add a while loop. While access pygame dot mixer dot music, call the get busy method. This returns a boolean. If our song is busy, if it's still playing, then we will call the time module's sleep method and sleep for 1 second. Once the song finishes, or we and we in Python today. Multithreading, so yeah, I'm going to talk about multithreading in Python today. Multithreading is used to perform multiple tasks concurrently. Think of it like we're multitasking. We're performing a few different actions at once. For example, I could study and listen to music and eat something at the same time. Multithreading is good for I/O-bound tasks, I/O meaning input-output, such as reading files or fetching data from an API. Things that may take some time to do, and we don't know when it's going to end exactly. To use multithreading, we'll import the threading module. Import threading. We access the threading module, then call the thread constructor, and pass in a target function. What we'll do for this demonstration let's say we have a button. We'll import the thread, such as reading files, I/O bound to music, and eat some different actions concurrently. Think of it like we're multitasking. We're performing a few different actions at once. For example, I could study and listen to music and eat something at the same time. Multithreading is good for I/O bound tasks, I/O meaning input-output, such as reading files or fetching data from an API, things that may take some time to do, and we don't know when it's going to end exactly. To use multithreading, we'll import the threading module. Import threading. We access the threading module, then call the thread constructor, and pass in a target function. What we'll do for this demonstration, let's say we have a bunch of chores to do. We have to walk the dog, get the mail, and take out the trash. Let's define some functions to handle that. We have a function to walk the dog. Then I will print the following message. You finish walking the dog. Let's create a function to take out trash. Then we will print you take out the trash. Then another function of get mail, as in get the mail from the mailbox. Then I will print you get the mail. Just to simulate these functions taking an indeterminate amount of time, I'm going to import the time module to help us. Let's say walking the dog takes 8 seconds. I will access the time module, call the sleep method, and pass in 8 for 8 seconds. When we call the walk dog function, we'll wait around for 8 seconds, then finish walking the dog. This chore will take quite a bit of time to complete. Taking out the trash, it's fairly quick. Taking out the trash will take 2 seconds. Getting the mail will take 4 seconds. Let's call these functions and see what happens. We will begin by walking the dog. I will call the walk dog function, followed by take out trash function, and the get mail function. Here's the result. We're going to wait around for for 8 seconds until the walk dog function is complete. Right about now. You finish walking the dog, you take out the trash, and you get the mail. These functions are running on the same thread, the main thread, our main Python program. We have to complete these chores in order, one by one, because they're all running on the same thread. Instead of walking the dog, and then when we're done, taking out the trash, and then when that's done, we get the mail. We could accomplish all three tasks at the same time. Let's say we have a thread object. We could say thread 1, or to be more descriptive, let's say we have chore 1. Let me zoom in a little bit. Chore 1 is going to contain a thread. We will access the threading module, call the constructor for a thread. We have to pass in a keyword argument of target. What is the first chore that we have to do? Let's walk the dog. To start this thread, we will take our thread object of chore 1 and call the start method to start it. Okay, let's do this with chore 2. Access the threading module, call the thread constructor, pass in a target, then the name of a function, take out trash. Chore 2 dot start. Start. And then we have chore 3. I'll just copy what we have, because I'm feeling lazy. Chore 3 will be get mail. Here's the result now. We finish taking out the trash first. Then we get the mail. Then we finish walking the dog. So we're executing these functions concurrently. We're multitasking. We're taking out the trash and getting the mail and walking the dog all at the same time. One thing that I did want to point out, notice how we finished taking out the trash first, followed by getting the mail, then walking the dog. These tasks finished in a different order, compared to when we weren't multi-threading. That's because taking out the trash finished first. It took 2 seconds, getting the mail took 4 seconds, and walking the dog took the longest. It took 8 seconds. Previously, we finished walking the dog first, then took out the trash, then got the mail. When all the chores are complete, I would like to print a message. I will print the following. All chores are complete. Here's what happens currently. We get this message that all chores are complete, but we haven't finished any yet. We're still completing them. There may be at times you want your program to wait for all threads to finish before we print that confirmation message that all chores are complete. We're going to use the join method. Take each thread, use the join method. We'll do this with chore 2 and chore 3 as well. With the join method, we will wait for these threads to finish before continuing with the rest of the program. Here's the result now. You take out the trash, you get the mail, and you finish walking the dog. All chores are complete. When constructing a thread object, and we have a keyword argument of target, if some of these functions take parameters, for example, with the function of walk dog, let's say we have a first name. I will convert this print statement to an F string. We will display first for the first name. You finish walking whatever your dog's name is, and that function accepts arguments. Function arguments. Now, since this is a tuple, if we only have one argument, we have to end that tuple with a comma. You finish walking Scooby. All chores are complete. If we were missing this comma, this is what would happen. We're no longer passing in a tuple. What if we have multiple parameters? Finish walking Scooby. Last, you take out the trash. You finish walking buddy. So that is multithreading. It's used to perform multiple tasks concurrently, as if we're multitasking. We're executing multiple functions at the same time. Multithreading is good for I/O bound tasks such as reading files or fetching data from APIs. And well, everybody, that is an introduction to multithreading in Python. Hey everybody, in this video I'm going to show you how we can connect to an API using Python. In this demonstration, we're going to connect to the Poke API. To get some information on a Pokemon of our choosing. I'm assuming that most of us are familiar with Pokemon. I thought it'd be a fun example. So according to this API, we can look up a Pokemon, such as Pikachu. Then we can get the stats for Pikachu.
Or a game jam or something, you know? Just like a channel hackathon where we just like hack away for hours.
such as Pikachu's name, height, ID number, and all sorts of moves and abilities that a Pikachu may have. We will need this URL, but we'll handle that later. Our first step is that we're going to import the requests library to make an API request. However, when I run this, I have a module not found error, no module named requests. Requests is one package we'll have to install. It's not normally included with the standard Python download. If I was to go to my project folder, go to my virtual environment, library, site packages, there is no package for requests. We'll have to download that. With PyCharm and VS Code, there is a built-in terminal that we can use. To download the request package, we can use pip. Pip is a package manager for Python. It's normally included when you install Python. We'll type pip install requests. It'll take just a second. And now we have that package of requests within our project folder. If I run this again, that error goes away. Process finished with execode 0. That means there were no errors. Going back to our Pokemon API, we will need this URL. URL. Away. Process finished with execute 0. That means there were no errors. Going back to our Pokemon API, we will need this URL. Let me zoom in so you can see it. I'm going to store that as a base URL, so it's easier to work with. For convenience, I'm going to create a function name. Get Pokemon info. To get some info on a Pokemon, we'll have to pass in the name of a Pokemon. For now, I'll write pass. Outside of this function, let's say we have a variable of Pokemon name. Pick a Pokemon. I will pick Pikachu for now. Then I will call the get Pokemon info function. Then pass in my Pokemon name. Remember that your parameters can be named different than your arguments. When you send data to a function, you can rename it to something else, temporarily. Now that we have the name of the Pokemon we would like to look up, we can complete the URL. This will be an f-string. So with our Pokemon API, we have the base URL, followed by the word Pokemon, then the name of a Pokemon. So we have the base URL. I'll add a placeholder and insert it, / the word Pokemon, / the name of that Pokemon. In this example, it's going to be Pikachu. We now have the full URL. We'll access the request module, use the get method, and pass in that URL. This method is going to return a response object, which is going to be Pikachu. We now have the full URL. We'll access the request module, use the get method, and pass in that URL. This method is going to return a response object, which I will assign to response. Response is a response object. And I'm just going to print our response just to see what we're working with. Here's our response object. It has a status code. And to this, use the full URL. We'll access the request module, use the get method, and pass in that URL. This method is going to return a response object, which I will assign to response. Response is a response object. And I'm just going to print our response just to see what we're working with. Here's our response object. It has a status code. This is an HTTP status code of 200. $200 means the response was okay. Here's a few examples of response codes. You're probably familiar with 404, not found. So we are looking for 200. The response is okay. After we get our response, I'll add an if statement. If our response object does have an attribute of status code to read what the status code is. If this status code is equal to 200, that means the response is okay. but for now, I'll write pass. Else, I'm going to print the following. Else, I'm going to print failed to retrieve data, and I will print the status code of the response object. So temporarily, I will print data retrieved if it was successful. I can't spell. Okay. We have our data. Data was retrieved. If our status code of our response object is equal to 200, I will take our response object and use the JSON method. Our response is a JSON format. Using this method, we'll convert it to a Python dictionary. It will consist of key-value pairs, much like a JSON file. But I'm going to assign that to a variable of Pokemon data, so it's easier to work with. Then I will print our Pokemon data. So here's the data on Pikachu. It's really difficult, so it's easier to work with a variable of Pokemon data. Assign that to a variable pairs, much like a JSON file. Dictionary. Our response object is equal to 200. I will take our response object and use the JSON method. Our response is a JSON format. Using this method, we'll convert it to a Python dictionary. It will consist of key-value pairs, much like a JSON file. But I'm going to assign that to a variable of Pokemon data, so it's easier to work with. Then I will print our Pokemon data. So here's the data on Pikachu. It's really difficult to read all this. You can see some keywords. We have abilities, base experience. This is an extremely large dictionary. Once we have our dictionary, I will return that dictionary of Pokemon data back to the place where we call this function, and I will store that as a variable. Pokemon info equals get Pokemon info, pass in a Pokemon's name. And now we should have a dictionary that we can work with. Let me zoom out. If our dictionary exists, we can use the if keyword. If Pokemon info, if that's true. If it exists, this will be true. I will print the following. I'll use an F string. To access the value of a dictionary, we can access it by a key. We'll take our dictionary of Pokemon info, access the key of name. Let's see what happens exactly. We get Pikachu. Let's get Pikachu's ID number. We will access the key of ID. The given value is 25. Pikachu's the 25th Pokemon in the franchise. Let's get Pikachu's height. Pikachu's height is 4. I don't know what unit of measurement they use in that franchise. 4 feet or 4 inches? I don't know. Let's get Pikachu. Pikachu's weight. Pikachu's weight is 60 pounds, 60 kilograms. I don't know. Just to make this look nice, I'm going to add name, ID, height, and weight. That looks much better. Let's pick a different Pokemon. I will pick my favorite Pokemon of Typhlosion. Failed to retrieve data. Does that have to be a lowercase t? Yes, it does. Okay. So name, Typhlosion. I'll follow the name with the capitalize method to make it capital. There we go. So my favorite Pokemon is Typhlosion. ID is 157, Typhlosion's height is 17, and weight is 795. Alright everybody, that is one way in which we can connect to an API using Python. Also, tell me what your favorite Pokemon is in the comment section down below. Alright everybody, in today's video we're going to get started working with the PyQt5 graphical user interface, also known as a GUI, GUI. In this topic, we'll be creating a basic window. Also known as retrieve data with There we go. So my favorite Pokemon is Typhlosion. ID is 157, Typhlosion's height is 17, and weight is 795. Alright everybody, that is one way in which we can connect to an API using Python. Also, tell me what your favorite Pokemon is in the comment section down below. Alright everybody, in today's video we're going to get started working with the PyQt5 graphical user interface, also known as a GUI, GUI. In this topic, we'll be creating a basic window. So let's get started. Alright, the first step is that using pip, we're going to install the PyQt5 package. Open up a terminal. Both PyCharm and VS Code have a built-in terminal that you can use. We're going to use pip, that is Python's package manager. Pip install PyQt5. Enter. And this might just take a second. Once your download has finished, you should have a package within your site packages folder named PyQt5. We can work with it as long as we import it. First, we are going to import the module of sys. Sys meaning system. This module provides access to variables used and maintained by the Python interpreter. Then, from the package of PyQt5, do pay attention to the capitalization. It's easy to mess that up. Use dot to access the module of Qt widgets. Widgets are the building blocks of a PyQt5 application. They begin with Q. That helps distinguish them from widgets from other libraries. They typically begin with Q. From this module, import the following widgets: Q, application, and Q, main window. Here's some boilerplate code that we have to write in order to get this application up and running. First, we will create a class of main window, which will inherit from the class of QMainWindow. By inheriting from the parent of QMainWindow, we can customize our own windows to display to the user. We will need a constructor. Let's define that. Define dunder init. There will be no arguments currently besides self, and in case we have to pass any arguments to the parent of QMainWindow, we will access the superclass, that's the parent, and call the parent's constructor. But currently, we don't have any arguments to pass in. We will return to this class momentarily. Let's define a function of main. When we begin this program, we will call the function of main to begin the application. For now, I'll write pass. If we are running this file directly, let's add the following if statement. If dunder name is equal to a string of dunder main, if we are running this file directly, call the main function in order for us to begin. If that's true, we will call the function of main. Within the main function, we will create an app object. App equals, we will call the constructor for QApplication, that class. But there's one argument that we have to pass in. We will access our module of sys dot argv, meaning arguments. So by passing in this argument, this allows PyQt to process any command line arguments intended for it. That's if we use command prompt or terminal. We won't be doing that in this series, but you may someday in the future. It would be a good idea for us to future-proof our code. Otherwise, you may see people pass in an empty list. So we now have an app object. Next, we will create a window object. Window equals call the constructor for our class of main window. Currently, we don't have any arguments to pass in. We have an app object and a window object by calling their respective constructors. Now, if I run this program currently, our window is not going to show. The default behavior for a window is to hide it. In order to show our window, we will access our window, call the show method to show it. It's only going to appear for a brief second when I run this script. I don't know if you saw it, but it pops up for a brief second. We need to ensure that the window stays until we interact with it or close it. After we show our window, we will access our module of sys, call the exit method. The exit method ensures a clean exit of our program. Within our exit method, we will pass in as an argument our app object. Our app object has a built-in method of exec underscore, and this is a method, so we can call it. This is the execute method. There is an underscore character after exec for execute. pound find a city equals error. And then we'll just print it in case there are using this font. It's color. We will start CV, which means arguments. Return. Let's return that. A violent gust of wind, a squall. 781 is for a tornado. Else if our weather ID is equal to 781, return a tornado. 800 exactly is for a clear sky. Else if our weather ID is equal to 800, return to our window to not display. Let's look up Miami. We get scattered clouds. It's 94 degrees. Los Angeles. Get the weather. We have a clear sky and a sun. Now, there's one fix we need to make. Let's say that I make up a city again. Blah, blah, blah. Get the weather. We should clear our emoji label and the weather description. But our error label, this with able to clear description are cleared. Okay, what if test? Please grid. We 8 degrees app.
Hi, hello. வணக்கம் மக்களே. இந்த virtual environment create ஆகும். ஓகேவா? இங்க அழகா சொல்லுது வந்து notice a new environment has been created. Do you want yes கொடுத்தலாம். உங்க particular project இதா அந்த folderல உள்ள போனீங்கன்னா enter தட்டினாலும் இந்த environment இங்க பாருங்க வந்தத பாத்து இந்த அடுத்து ஒரு மெத்தட் இருக்கு.